Hello students, friends. Today I can explain about session number 46. In this session you can see about the applications of transistors and that the phase shift oscillator. So phase shift oscillator, the principal circuit operation and the expression for the frequency for oscillation. So this is the circuit diagram for phase shift oscillator. I used here NPN transistor and this is your RC phase shift network. A phase shift oscillator can be defined as it is one kind of linear oscillator which is used to generate sine wave output. A phase shift oscillator circuit is shown in circuit diagram. It consists of three RC feedback network for producing total phase shift of 180 degree. That is 60 degree per section. So this is one section. Here you can get 60 degree. In the second section you can get 160. 60 means total 180 degree. This signal is feedback to the base side. Base circuit. Since C amplifier produces a phase reversal of input signal, total phase shift is again 360 degree or 0 degree, which is essential for regeneration and hence for sustained oscillations. The value of R and C are so chosen that RC section produces a phase advance of 60 degree. You have to choose R and C value in each phase. Each section gives rise to a 60 degree. It is found that phase shift of 180 degree occurs only at one frequency, which becomes oscillator frequency. The circuit is set into oscillation by variation caused in the base current is amplified into a collector circuit, and hence it is then again feedback to RC section. Here again you have to feedback here. This is feedback. The circuit will stop oscillating if the phase difference from 180 degree. Hence, in each phase shift oscillator circuit, the voltage divider R1, and R. These are the voltage dividers, provides DC emitter base bias. Also RC controls collector voltage, and RE and CE provides temperature stabilization and prevents AC signal generation. The oscillator's output voltage is coupled to the load by the capacitor C out. The frequency of oscillation for RC oscillator is given by F is equal to 1 upon 2 pi RC into square root of 2n, where F is the frequency, R resistance, C is the capacitance, N is number of RC phase shift stages. In our case, N is equal to 3. So this is the circuit operation for the phase shift oscillator. The advantage of phase shift oscillator is the oscillator circuit designing is easy with basic components like resistors as well as capacitors. This circuit is not expensive and gives excellent frequency stability. These are mainly stable for low frequencies. The circuit output is sinusoidal, that is somewhat distortion free. The frequency range of this circuit will range from a few hertz to 100 of kilohertz. Disadvantages of this phase shift oscillator is the output of the circuit is small because of the smaller feedback. It requires 12 volts battery for developing a suitable huge feedback voltage. It is hard for the circuit to create oscillation because of the small feedback. The frequency stability of this circuit is not good to compare with Wien-Bridge oscillator. The applications of this phase shift oscillator is, this phase shift oscillator is used to generate the signal over an extensive range of frequency. They are used in musical instruments, GPS units and voice synthesis. The application of this phase shift oscillator includes voice synthesis, musical instruments and GPS is the most familiar one. So what you learned in this session, the phase shift oscillator, then circuit operation, advantages and disadvantages of phase shift oscillator and applications. So thank you.